Good afternoon. My name is Kevin Zhang. I am the Senior IT Manager of the Center for Panel-Omic Sciences of the Li Ka-shing Faculty of Medicine of the University of Hong Kong. So a bit of background, university-wise, as you can see that, I think we recently ranked 17 of the QS World University ranking as a university as a whole, and then ranked 19 in the Times Higher Education World University ranking under the subject of clinical and health. So what we do, in simple terms, and our mission is to provide a platform for our researchers to be able to perform holistic-wise research from genomics all the way to hopefully cure 2 diseases. So why do we call ourselves Center for Panel-Omic Sciences? Panel-omics word, we actually created it. It's a combination of panoramic and multi-omics, so panel-omics, okay? So what is multi-omics, right? I'm sure you heard about genomics, okay? So multi-omics is beyond just genomics, which is just a foundation. We are talking about epigenomics, transcriptomics, proteomics, and metabolomics, okay? A lot of omics, okay? We are comprised of 9 core platforms, including the biobank core, where we keep our samples under -80 degrees Celsius freezers. And also the genomics core, proteomics and metabolomics core, bioinformatics core, which is where we perform the data analysis with the data that is sequenced through the sequencer. We also have imaging, flow cytometry, bioresearch support, bioreagent, and also the latest, actually established last year, the Li Ka-shing cryo-EM laboratory. And also the lab of cellular therapeutics, okay? So again, the idea is to hopefully, we would be able to look into, from a holistic point of view, approach to achieve like disease cureness and hopefully some, medicine. So who we serve? In addition to, obviously, Hong Kong Faculty of Medicine, we also serve other faculties such as, dentistry, engineering, science. And we also serve the 7 HK Center funded by Hong Kong government, established in the Hong Kong Science Park, which they do a lot of research, and we also support them. And also other Hong Kong U academics, such as UST, CUHK. And there's also this Hong Kong Genome Institute, okay, which is the first ever created, again, funded by the government, to hopefully create a genome bank. Again, the idea is to further, have research on and hopefully have diagnosis in the future, mainly targeting the various diseases. We're also supporting hospital authority with different hospitals. So we're now serving more than 1,000 users, or more than 300 research groups. And over the past 12 years, we have already completed more than 10,000 job requests and over 70,000 samples processed. And so we have been supporting the various research groups to periodically be able to publish high-impact research papers to the famous medical journals such as Nature, Nature Cancer. So how AI can help? This is one of the examples in life sciences, whole genome sequencing, okay? The idea is to sequence the whole genome. Supposedly you can see everything. So this is a typical workflow, to starting with sample preparation, extraction, library preparation, sequencing, and then the data analysis part, reporting. So where AI comes in and help is particularly in the data analysis step, including quality control, variant calling, read alignment, and also variant annotation. Another example that, of the Cryo-EM lab, this AI can also help in particularly in the area of particle picking process in the single particle analysis step of the Cryo-EM process. So again, it's sample preparation, data collection, and then we do image processing. And that is where particularly AI can help on to automate the particle detection, reduction of false positives and negatives, speedier and more efficient and more accurate. This is one of the papers recently published, not recent, actually last year, that published to the Nature Cancer Journal regarding to the liver cancer research. So what are the challenges that we face? Because today's topic is about building the AI-ready IT infrastructure. So we got to look into the challenges we face in order to design what kind of infrastructure should we build. So for research, not just about multi-omics research, basically for all kinds of research, reproducibility is a very key element. We have to make sure that every time when we use the same set of data, same set of methods and software, we will produce the exact same result. So in terms of IT, we have to make sure that the environment is consistent and stable, both hardware-wise and software-wise. So another challenge is we currently have more than 600 different analysis software, not to mention different versions of them, okay? So you can imagine the complication of this kind of environment. And they're mostly Linux-based, usually not using GUI, but writing script to run in a pipeline format. Obviously, we are generating a lot of data, okay? And it's growing exponentially. And one key point is, typically, we will not delete the data. We'll just keep pretty much forever. Now, obviously, with that kind of data, we need a lot of processing power to compute, to process, okay? And of course, when you talk about a lot of data, you have to make sure that they are moving fast enough in the network between storage system, between storage and compute and the servers. So we have to make sure that there is a good network. Security, obviously, we have to make sure that data, no matter is at rest or in transit, they are all secure. And so what are the challenges of AI and machine learning? Because a lot of GPUs or NPUs will be used, a lot of heat will be generated. So obviously, power consumption is high, and we have to make sure that there is a good or efficient cooling system to ensure that they're cool enough, okay? And as said that, it also requires very high-speed and low latency network. And also the storage has to be very high performance. So we typically would recommend to have all flash, all SSD. Rapid data growth. So with these challenges in mind, we're looking at 6 design principles. First of all, scalability, okay? The idea is to ensure that, because sometimes when you do research, you're probably using 2 servers to start with, but at other time, you could be using 100 servers. So usually in your local area, you won't be able to have such big facilities, or you won't be able to scale with that immediate sense. So how do we make sure that we can expand it and scale it up and horizontally? And also to the cloud, if needed. Agility, we have to be able to flexibly assign our resources to various purposes in order to maximize the usage. Portability, it can be run anywhere, meaning that, again, this is to do with reproducibility as well. And also, if you want to run it locally versus you want to run it in the cloud, it has to be portable, that you can do it anytime as you like. Availability, that is quite important because typically when we do a research, it will take at least days and typically weeks. So imagine that if it's down at the last day of the week of the research, you actually lost the whole week time and you have to redo everything. So we have to ensure that the system, the IT infrastructure is available, if not 100%, but close to it. Visibility, I would say this part is not so much about building the infrastructure, but after it's built, when you maintain it, you have to make sure that you will know what is happening at any time. Security, it goes without saying. So in an IT infrastructure for AI, we are usually talking about the following components, which include, first of all, you got to have a place to put your machines and equipment. So data center. So we actually currently have one of the Huawei's modular data center implemented in one of our data centers that we're using a in-row cooling so that you can scale as you need. When you add more rack, adding more equipment, I can also add another aircon unit in it in order to produce that kind of cooling power required. So particularly for smaller data center, it would make sense to use a modular data center with in-row cooling rather than the traditional underfloor cooling and with crate unit around the data center. High performance storage, as mentioned that, because in AI, there will be a lot of data, and not just the amount of data, but the different types of data, including very small file, a lot of files, a very big file. So we have to make sure that we have said that we do recommend to have and to use all flash. So you don't have to worry about the tiering between hard drives and your hot tier. Compute resources. In AI world, obviously, we have to use GPU and newer NPU. And from time to time, we also have to use CPU because not all the software, as I mentioned, the 600 plus software, not all of them will be supporting GPU. So we also need to have GPU and CPU. Network. So let's take a look at this diagram. This is a very typical kind of design where you have spine and leaf network. So I suppose pretty much these days, when we talk about design, it will be pretty much like this, especially for AI. You will want to have as fast as possible in terms of bandwidth, right? So obviously, I think 800 gigabit type switches is already out. So if you have the budget, always go for the fastest one. Otherwise, I would say 400 gigabit will be really good enough in most of the situation. So on the bottom left, compute, as I mentioned, that we will have mostly GPU server and AI. We will still have to have CPUs nodes sometimes. And we will also have VM, virtual machines, okay? That's one of the ideas to maintain the reproducibility. And on the bottom middle, storage. We're currently using this Ocean Store Pacific 9900 series with all-flash storage, which actually does the job very well. So, and also, as I mentioned, that because our data basically will be kept forever, so it is also important to make sure that we have an archive system to keep them. because you don't want to put all your archive data on the expensive storage. Comparatively expensive. So we also need to have a very comprehensive security framework in order to ensure the security level. So this, I think, is a bit small here, but I would pretty much say that 3 levels, okay? First of all, you have to have a firewall, obviously, in your parameter. And then at the endpoint, you want to have the XDR, Extended Detection and Response System, which is quite different from traditional antivirus system, okay? And also, I think more importantly is you want to have dedicated security personnel, in this case, Security Operations Center, to be monitoring everything, including all the logs from the firewall, all the logs generated from the XDR client, to a centralized location, and they do analyze 7/24. So when something happens, they will react, they would prevent, they will fix, and they will also do forensics if so unluckily you got hit or hacked. Real-time monitoring, as I mentioned, it's more to do with the ongoing operation and maintenance of the system that you have built, because there's got to be problem, hardware problem, software problem, compatibility problem, security problem. So you cannot solve a problem or deal with a problem if you don't know what it is. So you must be able to view what is happening at real time, anytime. And you have to have the capability to be able to correlate this different thing, these different issues, in order to prevent issues from happening. So I'd like to wrap up with this presentation with a quote I like. The best way to predict the future is to create it, by Peter Drucker. And let's create a good future together. Thank you.